for map, you know,
Uh-huh.
because the words are not the same in Danish. But those ones I've not seen.
Yes. Well, you have a wonderful English. You speak English without any accent at all. That's
Oh, thank you.
impressive, yes. It's funny, I just ended up working with a Russian kid who is just starting college in the United States. And
Uh-huh.
he received his entire high school education in Russia, and he dealt with the same problem, is that the terminology was what gave him most of the difficulty.
Yeah, and I'm also thinking that a lot of the problems I had on the GMAT is that I simply did not understand what they were actually asking me.
Okay.
But you can only get better by, you know, practice.
Yeah. If I say that y is directly proportional to x, it means that there is some k. And when x goes up, y goes up, but it might be y equals 2x, it might be 4x. It just means that
Yeah.
they're directly proportional. If I say that y is inversely proportional,
Uh-huh.
it means y is equal to k divided by x, which means when x goes up, y goes down. When x goes down, y goes up.
Mm-hmm.
Okay?
Okay, that makes
So
sense.
those two concepts are definitely worth knowing. And when they give us a problem like this, they're saying 2x and y plus 2 are inversely proportional. So that allows me to say, well, 2x is equal to some k divided by y plus 2. There is a inversely proportional relationship. Now,
Why is it, can I ask? Why is it not 2x under the k, like in the
it
one
could
right
be
above
either
it?
way. I could have
It
written
could be
this,
either way.
I could
Okay,
also
that's
write
easier.
y plus 2 is equal to k over 2x.
Okay, so that doesn't matter.
It
Okay.
doesn't matter. The fact that they started with the 2x is why I wrote 2x on the left.
Okay.
Okay. Now the next thing they give us is when x is 1, y is 3, and that's going to allow us to solve for k. In other words, when I plug in 1 for x,
It'll be 2 on the one side. And then it'll be k divided by 5.
okay, so k is equal to 10. Now, if we go back and rewrite our formula, we have 2x is equal to not k anymore, but 10 divided by y plus 2. So now I can solve for x when y is 2. I'm going to plug in 2 for y, so 2x is now equal to 10 over 4. So x is equal to 10 over 8, which is 5 over 4.
So 2x is equal to, I'm sorry, I'm just trying to
That's
read.
okay.
2x is divided by 10, so then you said 4 times 2. Did you move over?
Yeah,
So did you
basically
start
I,
with 4? Yeah, so you said 4 times 2 is 8, and then to get x by itself, you just said 10 divided by 8, which then you, they're both into 2, so that's 5 and 4.
right. In other words, I was able to solve for x when y is equal to 2. Because I know what k is. K is 10 for this particular proportional relationship. So when y is equal to 2, x is 5/4. So what is 8x squared equal to?
So that would be 5/4 squared.
Times
So
8.
yeah.
Okay.
So and do you call this fractions, the 5/4?
Yes.
Is that called fractions in English?
Yes.
So the 5/4, do you just put 5 in the
Well,
second, and then
you square the numerator and you square the denominator. So
so
the
then
8 is not
it's
being squared, but
it's 25 over 16.
right. Now,
And
if we
then say 8
simplify
times.
this,
Oh yeah, that's right. That always forget to do that. Simplify it first.
that's a good thing to do because if you were, this is going to be a type problem where you probably cannot use the calculator.
Yeah. Well, it's because normally you would say 8 times 25 divided by 16, but obviously this is way smarter.
Well, notice how much harder that is. That becomes 200 divided by 16, which now I have to do a lot of manual arithmetic to get the right answer.
Yeah.
Whereas if we simplify it first, like I did, then we immediately have the right answer, 25 halves, which is D.
Yes.
Okay? All right. Let's take a look at this one.
So it takes 12 seconds to cut the bar into 4 pieces, equal pieces. And it's asking how long it takes to cut the same bar into 7. Well, then it would take 3 seconds to cut one, right?
Not quite. How many cuts do you have to make in order to cut it into 4 equal pieces?
4.
Actually, only 3. That's the key.
Yeah, sorry.
1,
So
2,
4,
3.
3, yeah. And so then you have it, but it's 4 seconds per cut.
Okay.
And so then would you just say 4 times 7?
Well, ask yourself the same question. How many cuts do you have to make to cut it into 7 equal pieces?
Oh, then it would be 4 times 6, which is 24.
Exactly. And in
So
fact,
they want you to say 3 times 7, which is 21.
right. Right. They put the trap answers on there. They usually do.
Oh, yeah.
Notice also there's a bit of a shortcut here where if we realize that we have to make 3 cuts here and 6 cuts here, instantly we know that it's going to be 24 seconds. We don't have to really do much math at all.
Yeah, because it's a double up.
Exactly. So, but the secret is to figure out how many cuts you have to make for 4 cuts. Yeah. Okay, data sufficiency. The mathematical data sufficiencies I don't mind so much. It's the word problem data sufficiencies that give me trouble. I don't know about you. So from a morale point of view, go ahead.
Yeah, I think all of them just give me trouble because I make them harder than they actually are.
Okay.
So.
Well, this is called the stem.
Yeah.
And part of the trick here is to analyze them one at a time without considering the other one first.
Mm-hmm.
Because it's real easy to fall into a trap where you kind of are considering both of them.
Mm-hmm.
Let's go through one of them. First of all, how can I write this number 1?
Well, m is supposed to be 1 over m.
So that really is the same as this.
Yeah.
Okay. So, and that's the same as this.
M times 4.
Mm-hmm. Will that allow us to answer the question, what is k plus m?
No.
No, because in order to answer that question, we need to be able to say k plus m equals some number.
Yeah.
And you can't do that because k merely means it's 4 times m, and so m could be 1, k could be 4, m could be 10, k could be 40. So this is not enough by itself. Okay. How about,
So A and D are out.
yeah, and I agree
Actually,
that that's a good way to do it, but it might be simple enough that we don't need to do that. In other words, we might be able to get the answer immediately.
yeah, I usually just cross them out on my piece of paper because then I don't choose the wrong one.
Mm-hmm.
So,
Okay.
well,
All right.
if that's 64, then km could be 8 squared.
Okay. Does it have to be 8 squared?
It doesn't have to, but that's the only numbers I can figure that actually squared gives 64.
Well, notice it doesn't have to be squared. It could be, how about 4 to the third?
Oh, yeah, that's right. And
Okay.
then that means you cannot get one value for k plus m.
Exactly. That
Because you
means
only
since I was
know,
able to find two sets of numbers, and frequently that's the methodology you want to do, is if you
hmm
can find two different answers for k and m, that means you cannot answer it from this alone.
yeah. So
Okay? So we can't answer it from either one alone, so either we can't answer it or we can answer it with both of them.
hmm
Can we answer it with both of them?
well, you don't really get any values for k or m, set values for k or n in any of them.
Well, if we assume that the only two solutions for the second one are 8 squared equals 64 or 4 cubed equals 64,
hmm
does number one pin it down between those two?
It would have to be 8 squared.
Right, because we know that k is equal to 4 times m,
hmm
and that pins it down to that one right there. So with both pieces of information, we know that k is 8, m is 2, therefore k plus 8 plus 2 is 10, and we can figure it out.
Yeah.
Okay.
Yeah, I would probably have chosen to say that none of them worked right there because I didn't think about that one.
Okay. Now,
But that makes perfect sense.
yeah, okay, let's just, talk about the other pitfalls as they come up.
hmm
There's a lot of potential pitfalls in methodology that you can make with data sufficiencies.
hmm
Um, about number 4.
Okay, so filter A catches 90% of all spammy emails.
Okay.
Sorry, I'm writing it down because then I know what I'm doing.
No, that's fine. That's good. And I'd like you to think out loud because that helps me help you better.
Yeah. And then filter B is only 75% of all spam emails. And then it's asking if she uses both of them at the same time.
Actually, consecutively, and that might matter. She's going to use filter A first, and then she's going
And
to
then,
apply filter B after that.
okay, so
That's
then,
what
see, there
that
was
would
a
be.
word that was different than what I thought.
Uh-huh.
Well then, if you say that, so if all spam emails were taken, then it would be 100%, right?
Well, what this means is if I apply filter A only,
Mm-hmm.
it means if I got 100 spam emails, it's going to catch 90% of them, and I'm only going to get 10.
Yes.
And now when I apply the second filter to those 10 emails that hit my email box, how
You have
many
to
do I
flip it.
catch?
You have to take 75% of 10.
7.5.
7.5, yeah.
75% of 10 is 7.5. So how many emails get through?
2.5.
Out of the original 100, so what percent got through?
That's 2.5 divided by 100 times 100.
Which is 2.5%.
Yep.
Right. And you'll notice that the numbers I used here didn't really matter that I came down to a partial email. In other words, since they were looking for percent, because what she's really talking about probably is 1,000 span emails, of which 100 are going to get through, and then of which 75 get caught by the second one, so you'd end up getting 25 through. So
It would be the same.
yeah, it'd be exactly the same. Sometimes that fractional thing will get you, sometimes it won't, in the sense that, you know, if you're talking number of people or something, you can't have a half a person. But that was a different situation. Work problems. These can be very difficult, but
well, the formula for it is 1 over t is equal to 1a plus 1b plus 1c, because it's more than 2 people.
right, that is the formula. However, I have found a technique that works beautifully for me, simpler than this formula, and you might want to try it.
Yeah, I'm open for anything.
Let's leave this up here. Yeah, well, most people don't remember that formula, so kudos for you for even remembering it. What I do with work problems is I always figure out what part of the job they can do in a unit time period. Since everything is in hours here, let's figure out what part of the job Barbara can do in 1 hour. If it takes her 3 hours to finish the task, then Barbara does 1/3 of the task per hour. How about Ben? Takes the same task, 6 hours, so Ben does 1/6, and Daria does 1/9. Now notice that if they were all working together, we could figure out how much of the task they do in 1 hour. Because Barbara's still going to do her 1/3 of the job, Ben's still going to do his 1/6. So if we added 1/3 plus 1/6 plus 1/9, we get the part of the task that they can do, and that's why this formula works. Because if they can do 1/4 of the task in 1 hour, it's going to take them 4 hours, the reciprocal, to do the whole task. So let's read the rest of it here. Let's see, I didn't read the whole two. So Ben and Barbara start working together and finish half the task. Then Daria joins the two. They finish the rest of the task all together. How long did it take them to finish the entire task? Okay, let me erase that to give myself a little writing room here. So first of all, Ben and Barbara working together finish half the task. How long does that take?
Well, then I mean, if I was to have calculated it, I don't know if it's completely wrong, but I would probably have done the, you know, the AB divided by A plus B and then taken half of it. I don't know if that works.
Well, I'm not that familiar with using that formula since I don't do these work problems with that. Here's what I would do, and then we can go back and maybe look at that formula. But If they finish half the task, we can figure out how long that takes. Because Barbara does 1/3, Ben does 1/6 per hour. So
you have
that's
to
2/6. So they actually do exactly 3/6 of the task in 1 hour. That's exactly what they did, was finish half the task, so they must have worked precisely 1 hour. Had they finished if their work rates caused them to do 1/4 of the task in an hour, then we know that it took them 2 hours to do that.
How do we know that it's only 1 hour since she's 3 hours, he's 6 hours? Like how?
Okay, so Barbara does 1/3 of a task in 1 hour. Ben does 1/6 of it in an hour. So they're working together. So she's going to do 1/3, he's going to do 1/6. So if I add those two fractions together, I get 1/2. And that's exactly how much of the task they finished. So therefore, they must have been working exactly 1 hour.
Yeah, that makes total sense because it's,
Okay.
you could make that smaller.
So they started out and they took Ben and Barbara and Ben worked for 1 hour. And then Daria joined them, and they all three work for some period of time before they finish all the tasks. And we have an idea. We know it's going to be less than an hour, right? Because Ben and Barbara can do half of the job in 1 hour, and they've already done half of it. So if they were working alone, they would only take 1 more hour on their own. So we know that Daria is going to decrease the amount of extra time they're going to need to take. Well, all three working together can do 1/3 plus 1/6 plus 1/9 in an hour, but do they really need to do that? That's 3/9. Oops, excuse me, hold on. My lowest common denominator is 18. So if the three of them worked a full hour, they would do 11/18 of the task. And they only need to do half.
So you take half of 11/18.
Actually not. Well, hold on. I'm not sure what you do. I got to set it up as a ratio problem now. So 11/18 is to 1 hour. That's what they can do in 1 hour. But they really only need to do 9/18 because half of the job's already been done. So they only need to really do 9/18 of the job. So how long does that take?
Did you just take the 3/6 out of the 11/18 to get 9/18?
No, I came up with 9/18 because they only have half the task to do. They're not going to have to work a full hour. If they worked a full hour, they would accomplish 11/18 of the task, and half of it's already been done. So they don't need to do 11/18 of the task. They only need to do 9/18. So now I'm going to set it up as a ratio. If 11/18 of the task took 1 hour, what would 9/18 of the task take?
But how does, I think I just got lost of why 9/18 is only half the time of the 11/18. Since 11/18 is 1 hour.
Right.
How
But remember the problem. This is kind of a double step problem, because what happened was Ben and Barbara worked together alone and did half the task.
Yeah.
So we only have half the task to do remaining. That's where I got the 9/18.
I think I'm just confused of...
If all three of them work together, they can accomplish 11/18 of the entire job in 1 hour.
Yeah, that makes total sense. And then I got lost.
So how long if all three of them are working together, how long should it take them to do half the job instead of 11/18ths of the job? It would be some amount less than 1 hour, right?
Yeah, I definitely get that, but I just don't know how we got the 9.
9/18ths is 1/2. So
One,
let me replace that with
oh,
1/2. In other words, 1/2 is,
now I understand.
okay,
Okay, I got it.
okay. So now to solve for x, I'm going to cross multiply. And I'm going to multiply both sides by 18/11. So our answer is 18/22, which reduces to 9/11. Notice that that answer isn't on there, but it shouldn't be,
No,
because they already took 1 hour. So it's 1 hour plus 9/11ths of an hour. That's 20/11 hours.
because 1 hour is 11:11, right?
Yes.
That's
Yes.
where you just say 9 plus 11
Yes.
is 20. Yeah.
Yes. I'm sorry that this problem was as complicated as it was, because work problems are hard enough as it is, but it's much easier if it's a simple step problem. In other words, a typical work problem would say, okay, if she can do it by herself in 3 hours, he can do it in 6, and he can do it in 9. If all three of them work together, how long would it take? That's where you use that formula right there. That's all three of them working together. It would take them 11/18ths of an hour if all three of them work together.
Yeah. So, so you actually didn't really need the B plus B work, like how long they work. You just need to figure out that they worked half. You know, that they
No,
worked for
you
an
kind
hour.
of do need to B plus B, because your total answer is that amount of time. In other words, we don't know that Ben and Barbara worked for an hour without calculating it. I had to add 1/3 and 1/6 to come up with that 1/2.
Yeah, because you got 3/6, and that's half, and then you
Exactly.
know that that's 1 hour.
Right.
So half the job equals to 1 hour. Yeah, okay. I got that point.
Okay,
That makes sense.
good.
It just took a little
Hopefully,
bit.
I like to start off with, anytime I'm teaching anything, I like to start off with simple stuff. I don't believe you teach somebody how to ski by throwing them on the expert slope. I think you start out on the beginning slope, and then medium, and then hard. So I'm apologizing a little bit why they are giving us such difficult problems right off the get-go here, but
That's fine.
we'll get
I
by
mean, I
it.
understand it. I think it's just when you see it, sometimes, like, you know, getting used to, you know, you doing it in a different way. So,
Yeah,
it's
I
totally fine.
understand. Notice that 1 over A plus 1 over B plus 1 over C equals 1 over T. When I went to figure out how long it took all three of them working together, this is what I used.
Mm-hmm.
1 over 3 plus 1 over 6 plus 1 over 9 equals 1 over T. So T ended up being whatever. You do use this. It's just conceptually, rather than applying a formula, I've always felt that it made a lot more sense to use the other logic.
Mm-hmm.
Let's see here. Another data sufficiency, good. Worst thing about GMAT is if you try to go in and do nothing but data sufficiencies for an hour, it will demoralize you. I
I
hate to
know,
say
right?
that, but that's what I've discovered after tutoring this stuff for so long. So it's only 15, or it's 25% of the test, I believe. Am I correct, the data sufficiencies?
I would say that, but I counted on my test when I took it because I thought there was ridiculously many of them.
Uh-huh.
I actually had 23 data sufficiency questions out of 37.
Wow. Well, maybe,
I know.
wow. Well, maybe that was special for the practice test. I don't know.
No,
But
no, this was for the real test because I took a real test just to see
Okay.
how it was. And that's where I got the 500.
Okay.
And I put a little like marker on my thing so I could calculate it because I thought that there were so many that kept coming.
Mm-hmm.
So, and I had 23 out of 37.
Okay.
So that was a little
Okay.
more than I expected. But you know, you can. Then the lady told me that the computer no longer like differentiates between what type of question. It just gives you the. It only says easy, medium, or hard.
Okay.
Yeah, I don't know. So I had a lot of them.
Let's do one more. I have to leave somebody somewhere here in about 10 minutes. But
Okay.
let's take a look at one more data sufficiency here.
Yeah.
And then we can pick up from this spot whenever we meet next.
Uh-huh.
Is x equal to 3? And the first thing says x minus 2 to the x plus 2 equals 1. Well, the first obvious step is to plug in 3 for x and see if that's true, and it is.
Well, 3 minus 2 is 1. 3 plus 2 is 5. And 1 and 5 will still be 1.
Right. So x certainly, that's one value that works. But does it have to be 3? Is there any other number that works? In other words, if I can find another number, rather than trying to solve this algebraically for
that
x.
will not give 1. That will not make x equal to 3. That will actually say that it will be 1. But there's, I mean...
One thing to remember is that any number raised to the 0th power is equal to 1.
Mm-hmm.
That's a huge concept in math.
Uh-huh.
So find me another number for x that would cause this to be equal to 1.
Well, x could be minus 2.
That's it. So if x were minus 2, this would also be true.
Yeah. So then...
So 1 alone does not answer the question. Because it might be 3, it might not be 3.
Mm-hmm.
Now let's try to examine 2 without considering 1. And that may sound easy enough to do, but it's a real easy mistake to make, where by the time you're analyzing 2, you are still thinking that 1 applies.
Then you put it in again, right? The 3?
Well, another important concept to know is that any number taken to an exponent, no matter what the exponent, cannot be equal to 0. If I gave you a number, 5, and I said, well, put an exponent on that and make the whole thing 0, you would not be able to do that. There is no value for x that makes that 0.
Yeah.
Okay? So you can't make it equal to 0. So x is definitely not 3.
Which is a solid answer, so that means number.
Well, notice that if I substitute x for 3, I have 0 to the 3rd power. Is that equal to 0?
Yes.
Actually not. Believe it or
0 times 0 times 0, really?
well, 0 to the 0th power is equal to 1.
1, yeah.
3, or 0 to the 3rd power, that actually is equal to 0. It's kind of odd that 0 to the 1 power is 0, 0 to the 2 power is 0, but 0 to the 0 power is 1.
Yeah.
That's a strange mathematical, it's called the indeterminable 0 to the 0. So the question is, does that necessarily make x 3? It does. There is no other value that will give you 0 here other than x equal 3. Because x equal 3 is the only thing that makes the numerator 0.
Yeah.
So B should be the correct answer for 6. Let's just check. Whoops, I've got to open my answer sheet. And it is B. Okay. That's a very tricky one there. Very tricky. Because it's so bizarre that this is true that, I mean, most people would not believe this. That
right? Probably.
Most people would never believe this, the following. 0 to the 1,000th power is 0, but 0 to the 0th power is 1. This is definitely a true statement. You can use calculus to prove that, any number of things. Or you can use a graph to prove it. Take x to the x power and keep letting x get smaller and smaller and smaller and approach 0, and you get closer and closer to 1. So, okay.
Well, that makes perfect sense. Well, I jotted it all down, so at least I got it on paper.
And I'm recording this, and what I'm going to do is it takes me a few hours to process it, but after I process it, I will send you an email with a link to this recording, so even if you don't write anything down, you can still review it all.
Oh, great.
The recording has everything that I'm writing, plus both of our audio.
Yes. I just have one really fast question for you. I set up my PayPal, but I've never used it before. So now that I've connected it to my credit card,
okay,
do I then just transfer money because it says something via email, or?
You can send me money by just sending it to my PayPal account, and my PayPal account's ID is my email address. So if you make a payment and make it David Cowan 1949 at gmail.com, it goes directly into my account.
Okay, well, I will try and figure that out.
Okay, sounds good. And if you have problems or anything, we can get on a GoToMeeting session, and I can bring up PayPal and show you exactly how to do it.
Yeah, that would be great because I just wanted to tell you that I've never used it, so that if it didn't come right away, I'm really sorry.
Oh, no problem. I'm not worried about it. So.
Okay, well, well then I should set that up, and yeah, I can just email you and see when you're free next.
Okay. Yeah, my schedule is fairly open for the next couple weeks. My son is having his first child in Florida, and I do have to make a trip to Florida for like 4 or 5 days. But even there, I could probably work with you because I'll have a laptop.
Thank you. I mean, that's family, you got to do that. So.
Yes, for sure. You got to do it. And I'm
Well,
not sure when that's going to be because I don't know when the baby's. She's supposed to be born in 10 days. So
well, they don't always come on the day they're supposed to.
I know. How do I? Boy, I know that well. My first child was 3 weeks overdue.
Oh, yikes.
I know. That's not fun.
No. Well, I will just email you later today, and you can just, send me back whenever it fits.
Okay. Sounds good, Cecilia. And like I said, by late today, I will have a link sent to you that is a recording of this session.
Well, that's perfectly fine.
Okay.
Thank you so much. I'll talk to you soon.
Okay. Bye-bye.